All right, welcome back. We're going to look at writing formulas coming from a name of a substance. Words to symbols is our goal for today. So we're going to talk about two specific types of names. We're going to look at ionic names and also covalent names. Now, ionic names is what we're going to look at first, and you're going to have to identify that you're looking at an ionic name. Here's the giveaway is that you're not going to see a prefix inside the name. There's one exception, but for the most part, no prefixes inside the names. Here are your steps. Once you know that you have an ionic name, you are going to write the symbol and the charge above that portion of the name. And then you need to crisscross your charges. You need to cancel your charges, make sure the pluses and minuses equal in those ions, and crisscross to make that formula correct. And make sure that you reduce any subscripts that need to be reduced. If you have a 2 and a 4, they need to reduce. Or a 2 and a 2 would reduce down to just ones. Speaking of ones, if you happen to draw a subscript 1, you're going to just omit that. We won't use the subscript 1. And then you're not going to include charges inside your formulas. And finally, you might need to use parentheses around the polyatomic ion if one exists. So this is basically what you do. You're going to write your symbol and charge above the name. Here's your flow chart, your graphic of it. Check your charges, crisscross. And then don't write the subscript 1. Don't use a plus or minus sign anywhere inside your formula, and don't forget to use parentheses around a polyatomic ion. I'd like to show some examples of how you might do this. All right, here are some examples of how you would go about writing a formula from a name. We're going to figure out that these are ionic. All of these are actually ionic, but we know that they're ionic because in all three of these names, we don't see a prefix. So I'm going to just write an I next to the name so I can remember that these are all ionic. And then our steps was to make this more complicated task simpler by writing down the symbol and charge. So potassium is a K+1, and I know that in my head. You can also use your periodic table, the back side of it, to figure that out. And then iodide is I-1. So Ki. This would be subscript 1, which we will omit. We have magnesium sulfide. Magnesium is Mg+2. Sulfide is S-2. +2 minus 2. That would give us Mg2, S2. We're going to omit those 2's. We'll end up just with Mgs. So we crisscross. The 2's come down, but then we need to reduce because 2 and 2 both are divisible by 2. Calcium hydroxide, calcium Ca+2. Hydroxide is OH-1. So the 2 comes down, the 1 goes on the opposite side. Now a couple things to look at. OH, that's multiple atoms. That means we're going to need parentheses. This 1 can be omitted because we don't use subscripts 1. So we're going to have Ca. We set parentheses around the polyatomic ion, OH, and then the 2 on the calcium goes on the back side of the calcium, or excuse me, on the back side of the hydroxide. So these are 3 examples of ionic names going to ionic formulas. Now that we've learned about ionic formulas from the ionic names, let's look at covalent compound formulas. Now, when we look at this name of a substance, we're going to for sure see a prefix, possibly 2. That's how we know that we're in the covalent naming system. These are really easy. Once you have the prefix, you're going to write the number that that prefix represents above the name in addition to the symbol. So we'll take that name, turn it into a symbol, and put that prefix above the name as well. If that prefix is mono, it's 1, but if the first atom doesn't have a prefix, it's also 1. So the second atom will always have a prefix, but that first atom, if it's lacking a prefix, its subscript's going to be 1. Then we're just going to write those numbers that we just wrote above the name behind the atom's name, behind the atom symbol. Way to look at this, we can tell that this doesn't contain the word acid. So in some of my classes we have acids, and in chemistry fundamentals we don't have acids going on. So if your name does have a prefix, that first name, if there's no prefix, don't forget the subscript's going to be 1. We don't need to write it down in the formula though. all other prefixes will have a subscript. The second name, the prefixes are always going to be the subscript unless that subscript is 1 as well. So these examples of how to write out a covalent formula from a covalent name will be able to show us how we use these skills together. We know that these names are covalent because we see the prefix inside of them. So I'm going to just write a C so I remember that they're covalent, because that's going to help me remember that I need to use specific rules. So this first atom, carbon, its symbol is C. It doesn't have a prefix, so I know its subscript is 1. The fluoride is F, and then the tetra means 4. So I'm just going to write that as a symbol. I can omit the subscript 1. We don't write subscript 1s in formulas. And then the 4 belongs on the fluorine. Phosphorus, again, no prefix, so just P. The no prefix means there's 1 copy. The tri is going to be a 3, and then the bromide will be Br, where that 3 comes on the back side of the Br. So I'm going to write down the P, subscript 1, which we can omit, and then the Br, subscript 3. Finally, sulfur, again, no prefix, so just the letter S, symbol S, the 2, and then the O, oxide. This 2 is going to be the back side of the O, so SO2 would be my formula. So what you should have learned after watching this video is how to identify the type of name you're looking at so you can use the correct formula writing rules. Don't forget, if you don't see a prefix, it's going to be ionic, and if you do see a prefix, you have a covalent naming system. For ionic, you have to check your charges in crisscross. For covalent, you use the prefixes to determine your subscripts. Hope that helps.